write direct variation in 2.4 here. So basically what we're saying is y equals kx where k cannot equal 0. So it's k is some type of number and k is some type of constant term. So write an equation of a line. Basically what we have here is the length is x and the price is y, and the x is in inches and y is in dollars. So here's what we have. I need to figure out what that constant term is. I know that this is y. I know that that is x. I know that this is y and that is x, and this is according to direct variation. Y equals kx. That's why I saw the k here. This is y. That is x with your k. This is y. That is your x with the k. This is y. That is your x with the k. So since it's k times 16, the opposite is division. And it's the same for each of these. K times 18, the opposite is division. K times 20, the opposite is division. K times 24, opposite division. K times 30, opposite division. So to get rid of that 16, I divide both sides by 16. To get rid of the 18, I divide both sides by 18. To get rid of that 20, I divide both sides by 20. To get rid of that 24, I divide both sides by 24. To get rid of that 30, I divide both sides by 30. The 16s cross out. The 18s cross out. The 20s cross out. The 24s cross out. The 30s cross out. So I'm left with 18, 18, 18, 18, 18. Every single one gives me 18, which is actually kind of interesting. Well, when we're dealing with direct variation, you need that k, that constant term, to be the same. That's how you know if you're dealing with direct variation. And each of these, when you divide them, the k is 18. Thus, the data does show direct variation between k, and k equals the same thing for all of them.
How are you doing?
So we're giving another list here. It's the same thing. I have my y and I have my x. I have my y and my x. I have my y and my x. I have my y and my x and my y and my x. It's all the same. So to get them all by themselves, I divide each side by 0.5, divide each side by 0.7, divide each side by 1, divide each side by 1.5, divide each side by 2. So when I divide each side by 0.5, 0.7, 1, 1.5, and 2, I'm doing that to get the 0.5s to cancel, the 0.7s to cancel, the 1s to cancel, the 1.5s to cancel, the 2s to cancel. So when I do that, 2250 divided by 0.5 is 4500. I get 4900 here. I get 6400 here. I get 7,333.333, and I end up getting 10,200. They are not all the same. So thus the data does show no direct variation because the k is not the same. For direct variation, the k needs to be the same in every single one of these, and it wasn't. And since it's not, there is no direct variation in this problem.
Inconceivable!
So there's your homework. Pages 95 through 96, 14 through 28 even, 25 through 51 odd, 56 through 66 even, and 69. Yes, it looks like a lot of problems, but keep in mind, most of them go together. They're grouped together in a series of problems, and some of those direct variation problems will take you like 2 seconds to do. So if you have any questions or concerns, please shoot me an email, or you can take a look online to find some more examples on TeacherTube, on my own personal website, on the virtual tutor that I have on Moodle, or I have some other examples uploaded online. Thank you.